We have created really short videos to capture the main points of a book entitled Learning the Brainstem. The voice you hear is AI generated. LTB 8 continues our discussion of the rostral pons. In our very first video, LTB 1, we showed this MR image of high or rostral pons. But we have access to several photomicrographic, not radiographic sections at a higher level than what you see here. Let's compare them to each other. The image furthest to the left is highest or most rostral in the pons, and the image furthest to the right is lowest of the three. But we never leave the pons, and actually we never leave the rostral pons. Paying attention first to the basis pontis, I have superimposed a red rectangle over all three sections. Does the basis pontis look the same to you in each section? Certainly there are dark fibers that pass from side to side in each instance. We know, however, that fibers also pass up and down. The basis pontis seems to get smaller as we pass lower, perhaps. But what is happening at the lateral edges? The yellow arrows point to the lateral edge of the left basis pontis in each slice. Maybe you already know what the arrows indicate. But wait a moment. In the photomicrographs that I use, I focus just on the brainstem, and I exclude all surrounding structures. In this radiographic image, which we saw in LTB1, we identified what we called the arms of the pons. The middle cerebellar peduncles connect with cerebellum dorsal to it. Just for clarity, I place a yellow arrow at the left middle cerebellar peduncle. And this MR image is at a lower level than all these sections. So, the yellow arrows point to the first suggestions of the middle cerebellar peduncle in the left high pons. Let's now switch our attention to the dorsal aspect in each section. The red rectangle surrounds the pontine tegmentum in each case. Tegmentum is the standard anatomic term. We don't speak of a tectum or roof, as we did in the midbrain. When people speak of the pontine tegmentum, they refer to the dorsal aspect of the pons. The yellow arrows draw your attention to changes at the midline. Specifically, the crossing fibers of the superior cerebellar peduncle or the superior cerebellar decussation become less obvious at the midline as we move lower. Also, as we move lower, the superior cerebellar peduncle becomes clearer as a very dorsal and discrete structure on either side of the superior medullary velum. Important tracts pass throughout the pons. Some we have seen and named previously. We will concentrate on the pontine tegmentum, using just one of the axial images that we have used in this video. And let's enlarge the field of view. There is no escaping the need for some retrieval-based learning in medicine generally, and in neuroanatomy in particular. So, let me help with some flashcards. The red arrow points to the lateral lemniscus. The red arrow points to the superior cerebellar peduncle. For extra credit, grey matter is present between superior cerebellar peduncle and the lateral lemniscus. It is a parabrachial area whose nuclei are involved in sensory processing. Roughly at the level of the last red arrow, the red arrow now sits in grey matter in the vicinity of the locus ceruleus and its catecholamine-producing neurons. The red arrow points to the medial lemniscus. Spinothalamic fibers are located more laterally than medial lemniscus fibers. As just said, spinothalamic fibers are lateral to where the arrowhead sits. For extra credit, spinotectal fibers from spine to tectum of midbrain, specifically superior colliculus, also ascend in the same lateral area. Like spinothalamic fibers, they cross the midline in the cord rather than in the brainstem. We will encounter a descending tectospinal tract in a moment. It keeps company with MLF. The red arrow points to a rubrospinal tract. Fibers from red nucleus cross the midline almost immediately after they exit red nucleus. Then, as they descend, they move laterally towards the area of ascending spinothalamic fibers. The rubrospinal tract crosses the midline, but other fibers arising from red nucleus do not, such as those in the central tegmental tract. Medial to the superior cerebellar peduncle, the red arrow now points to central tegmental tract. The arrow points to the left side of the decussation of the superior cerebellar peduncles. When we visualize the decussation, think for a moment that at least one other tract decussates roughly at this level of high pons. For example, just lateral to the MLF is a tectospinal tract from tectum of midbrain, specifically superior colliculus, to spine. Its fibers have crossed from contralateral tectum roughly at this axial level. The tectospinal tract and the MLF remain in close proximity to each other throughout the brainstem. The red arrow points to left MLF. The red arrow points to PAG. Immediately in the midline, the red arrow points to a dorsal nucleus of the raphe, and the pontine raphe extends ventrally in the very midline pons. Grey matter of the reticular formation is on either side of the red arrow. The red arrow points to the superior fourth ventricle. The red arrow points to the superior medullary velum. Congratulations! You have completed a two-part tour of the rostral pons. In LTB 9, we will study the brainstem in relationship to the cerebellum in greater detail. As always, thanks for watching.